We're going to jump back into section 2.3. We actually had accomplished the, title of this section where we looked at the product rule and the quotient rule. But there's another piece of material in here that we're going to cover as well in 2.3, and that has to do with the trigonometric derivatives. Now, you've seen a couple of them already. What's the derivative of sine? Cosine. And what's the derivative of cosine? Negative sine. So we saw those back in section 2.2. They're considered simple rules. They're very nice and clean in the sense that they have this cyclic kind of feel to them. So that part works really nicely, and that's why they're grouped inside of section 2.2. These are a little bit messier. They don't have a cyclic nature to them in the same kind of way. But the derivatives are of the other four of the six trig functions. So the derivative of tangent is secant squared. So the derivative of tangent x is secant squared x. Cotangent is negative cosecant squared of x. Secant x is secant x tangent x. And cosecant x is negative cosecant x cotangent x. You have a fair bit of memorizing to do before Friday, and I understand that. So let me give you some sort of things to keep in mind that make this a little bit easier to keep all these straight. I feel like they kind of come in groups of two. Sine and cosine kind of go together, right? They have each other as derivatives more or less. These first two, tangent and cotangent, they also go together. And you can see that their derivatives are quite similar. Tangent is secant, cotangent is cosecant. They are squared as well, so they have that in common. The other thing that you might notice is, what was the derivative of cosine? Negative sine. What's the derivative of cotangent? Negative cosecant squared. And what's the derivative of cosecant? Negative cosecant cotangent. So anytime you have the derivative of a co-function, you're going to have a negative. And anytime you don't have the derivative of a co-function, that is, it's one of the other three, it's positive. So maybe that will help you to keep those straight too. Negatives and positives sometimes trip things up. Another thing that makes these more challenging to work with, as opposed to sine and cosine, is that sine and cosine, as they go back and forth between one another, just create another simple rule. If you were to take the derivative of sine and you found cosine, you could take the derivative of cosine again and just keep doing the pattern over and over again. But if you take the derivative of any of these, you create something that's more complicated, right? You've got a squared function, or you've got a product function, right? A function of products, right? So it makes something that's more complicated to work with, and again, why they're showing up in this section instead. So we're going to take a look at a few of these and work through how these go. So the first one, h of x, is equal to 1 over x minus 12 secant x. So we talked about how we could rewrite things like 1 over x in the past. How could I rewrite 1 over x so that I can use my simple derivative rules? Good. X to the negative 1. So maybe you don't need to see it rewritten. You can just think it through in your head. I actually think that's one that is quite helpful for me to rewrite before I do it. So I usually will. But then I'm going to take the derivative. So what's the derivative of x to the negative 1? Negative x to the negative 2, or negative 1x to the negative 2, right? How about, what's the derivative of negative 12 secant x? Good. It's like in uniform because it's coming from both sides of the room. You guys are all on track. Good. So negative 12 secant x tangent x. Okay. On a gateway, you would stop right here. For our purposes right now, we are going to clean up just a little bit, namely the negative exponent part, right? X to the negative 2. We're going to clean that up a bit. And so if I have this cleaned up, I would have a negative either on top or in front over x squared minus 12 secant x tangent x. Mm-hmm. Nope, not at all. I don't care at all. I care that can you take a derivative and do it correctly. It's about efficiency. It's about accuracy. That's it on the gateway. Yeah, you bet. All right, let's try another one. So on this one, this is a really common problem that shows up either, sometimes I have it on the gateway, sometimes I'll have it on the exam, or sometimes I'll have it on the quiz. I usually have something like this where I have trig functions multiplied somewhere. And undoubtedly about 5 or 6 of you are going to do the product rule the way that we can't do the product rule. You're going to take the derivative of sine, you're going to take the derivative of the cosine, you're going to decide that you're done. I don't know why that happens, but probably because it kind of doesn't look like a very complicated product. I think that may be why it happens. But it is, in fact, a product. I have 2 things that are being multiplied. I'm just going to do this to them so you can see them separated a little bit. But there definitely is a product rule here. Okay? So as I take this derivative, we rewrite the first piece. So I know we didn't actually review it, but let me go back here so I can catch it just so that I can say I did. The product rule, where'd it go? The product rule right here is that I take the first piece and I rewrite it. I take the derivative of the second, then it's addition, and then I take a derivative of the first piece and the original of the second. That's the product rule. So we're going to use that product rule right here. So the first piece, sine x, simply gets rewritten. Okay? And then I need the derivative of cosine. So what is the derivative of cosine? Negative sine x. And I'm going to write it this way right now, but if you want to just put the negative at the beginning, you totally can. We're going to clean things up in a little bit anyway, so it doesn't really bother me that I'm just going to sort of write this way. It is valuable to notice that you do need parentheses around the negative sine x. Otherwise, it's subtraction. So it is important because of the negative sign that we put that in parentheses. Then we'll have addition. Then I need the derivative of sine, because it's the first function. And that's cosine. Good. And then I need the original of the second piece. That's another cosine of x. Okay, so far so good? Okay, so on the gateway, you'd stop right there. We're going to do a couple of things as we look at this. One is that I'm going to put the negative in front because I have sine x times sine x. If you leave it as sine x times sine x, that's okay, but there is a condensed way of writing that, namely sine squared of x. And we can do the same thing with the cosine times cosine. Again, if you leave that the same, it's okay, but it's a little bit more condensed, compact to write it as cosine squared. It almost looks like this is one of your Pythagorean identities, but it is not. Why? Because there's a negative on one of them, right? So one of your Pythagorean identities says that the sine squared plus the cosine squared is equal to 1. Well, one of these is negative and the other one's not. So I don't have the ability to condense it to 1 or -1 or something like that at all. I simply am stopped at that point. Any questions on that one? Okay, let's try another one. I have it rewritten right. I do. Good. Okay, it's quotient rule. So let me show you again the quotient rule real quick since we jumped right in today. This is our quotient rule. Our quotient rule says that we take the denominator times the derivative of the numerator, and then we subtract the numerator times the derivative of the denominator, and it's divided by the denominator squared. It is very reminiscent of the product rule on top. It's just that it's a subtraction sign instead of an addition sign. Otherwise, they're the same. But then, of course, I have the denominator squared. So over here, we're going to do this problem using that rule. So g prime of x starts out by doing what? Writing the denominator, yes, which is tangent of x. Then I need the derivative of the numerator, which is -3. And then I have a subtraction sign because the quotient rule has subtraction between the two terms on top. Now I need the derivative of the denominator. So what is the derivative of tangent of x? Secant squared of x. And then I need the original of the top part, which is 2 minus 3x. And all of this gets put over tangent squared of x. Gateway, you stop. Please stop. If you don't, you're going to make a mistake. I mean, you just are. I mean, maybe not every single time, but it's going to happen, and you're going to be kicking yourself, and you're going to be like, dude, if I just hadn't simplified, I'd be done with this gateway, and now I got to come in tomorrow. So don't simplify anything, okay? For the purposes of working on all of your homework and tests and everything like that, of course, we are going to simplify this and make sure that we've got our algebra techniques in place. But the first piece, the tangent of x times -3, how else should I rewrite that to be cleaner? Yeah, we'll move the coefficient in front, -3 tangent of x. On this one over here, I'm actually going to do a distribution of these pieces, or actually maybe it makes more sense to say that I'm distributing this like this. So I have the negative secant squared times 2, so that's -2 secant squared x. And then I have negative secant squared of x times -3, so that would actually be a positive 3x secant squared of x. And all of this is over tangent squared of x. If there were the ability inside of some of this to simplify something that's like a simple trig simplification, for example, you had one on your exam, first exam, you know, where you had cosine over sine times sine, and you should cancel the sines. I'd expect you to do something like that. There may, in fact, be some more elaborate trig simplifications that could compact this a little bit more, but that's not what we're interested in doing here. We've simplified it to the extent that we need to. Everything's cleaned up. Nothing else combines in a simple way, so we're stopping there. Okay. Okay, last one. So what about this maybe looks more challenging than the last problem? Yeah, there's a 3 outside the parentheses, and we would like to clean that up just a tad before we start, just because it's going to make the process a little easier. The 3 outside the parentheses can simply be distributed through, right? So this can be 3 minus 3 sine x over the 2 cosine x. So there are occasions where simplifying what you're given to start with is really helpful. There's some times when it's just sort of irrelevant. You can do it or you cannot do it. But it's a good idea to stop and ask yourself, can I simplify this and need to make the rest of the process easier just to make sure. So we're ready to do the derivative here. So what do we start with? The bottom. So the bottom was 2 cosine of x. And I need that times the derivative of the top. So what is the derivative of 3 minus 3 sine x? Yeah, it is -3 cosine of x. Okay, it's negative because the negative is already there by the -3, right? But the derivative of sine is cosine. We'll have subtraction. And then we'll reverse it. So I need the derivative of 2 cosine x now. Good, -2 sine of x. And then we rewrite the second piece, 3 minus 3 sine x. And all of this is written over 2 cosine of x squared. Okay, so far so good?
I do have a question.
Yes.
Okay, so on the last one, you wrote it as tangent squared x, but on this one, it's the
I
whole
missed
thing.
it. Nobody caught me and said anything. You're right, I missed that. This should have been tangent squared squared. I apologize. Thank you so much, and I probably should have been paying closer attention to my notes. I'm sure it's right there. That would give me,
Why is
wow.
it squared?
Oh, never mind. Okay, I'm with you. You're asking me, good grief, I keep touching my screen the wrong way. You're asking me why I didn't write it like this. Is that what you're asking me?
Yes.
Okay,
And then
sorry.
you wrote it differently for this one.
Yeah, so I didn't write it like that here. I mean, the reason I just did it as tangent squared is because it didn't cause any confusion. Over here, I want you to be careful to recognize that the 2 is also going to be squared.
Okay.
So could you write the denominator as 4 cosine squared x? Absolutely, and we will here in just a second, actually.
So for the last one that we did, can
Yep.
we write it tan x squared and it would be the same?
Yeah, it's the same thing. Yeah, if it bothers you to have the squared between the tangent part and the x part notationally, I don't care where it's written.
Yep.
Here's what you can't do, though. You can't write this. And the reason you can't is because then there's a question of what's being squared. And actually the understood sort of general understanding of what that would mean is that it's the x that's being squared and not the tangent.
Okay.
So your two options are to either write it like this or like this. Thank you for drawing my attention to that. It's a good question. So over here at this point, we've done everything that the gateway would request for us to do. As we're simplifying, we are in fact going to do just what Lainey was sort of drawing our attention to recognize that we do have a 4 on the denominator and that we have cosine squared. And I'm still going to write mine like this because then I don't have to write parentheses. But if it bothers you, just put the cosine of x in parentheses and the squared on the outside. So we're going to clean up the numerator because this one actually cleans up a bit more than the last one did. So negative 2 cosine of x times 2 cosine of x times negative 3 cosine of x would give me negative 6 cosine squared. Is that okay? 2 is not good. Now over here, oh my goodness, I got a lot of negatives. So there's a negative right here, and we'll ignore that for the moment. And let's just multiply. Actually, you know what? Let's multiply these two negatives together, and then I'm done with this. That'll be positive because I'm multiplying the 2 sine of x through anyway. So I can multiply the 2 sine of x, clean through, times 3, and then times the 3 sine x. So I have positive 2 sine x times 3. So that's positive 6 sine x. And then I have the 2 sine x times negative 3, so that's negative 6. And I have sine x times sine x, so I've got sine squared of x. Okay, so the multiplication part, okay. All the pieces, all the signs. Okay, great. There's actually something I can simplify here using the very basic trig rules that I've asked you to take a look at again, the ones that are posted in Canvas. Do you see what I can simplify here to write differently? All right, tell me what you see.
I can get rid of that cosine. I can make that tangent, and I can make that one tangent squared. Hit dissect.
Okay, so I think there might be a simpler way of doing it. Malachi?
You could first factor out a negative 6, then combine cosine squared x and sine squared x to make 1.
Yeah, that's the one that's actually the quickest to simplify. What you're saying might work eventually to clean up to the same thing, though. So these two pieces right here have that same sine squared and cosine squared that we saw earlier. The difference is right here that they have the same sign. In fact, they both have a negative 6 in front of them. So if you were to factor it out, and I'll write a step to show it just so that when you're looking back at this, you're like, how did she do that again? There is a negative 6 that can come out, making that cosine squared of x plus sine squared of x. The part that I didn't highlight in the middle just gets left out of that factoring, which is fine. We're not forgetting it. We're just not using that feature right here. And then the part that's in parentheses is actually equal to 1. That's equal to 1. That's one of your Pythagorean identities. So this actually becomes negative 6. So all of this is equal to 1 plus 6 sine of x over 4 cosine squared of x.
Is that
Ashley?
second sign supposed to be squared?
Um,
Cosine squared x plus sine squared x.
yes, right here. Thank you. Yep, I left that one off piece. Yes, thank you for that. Okay, there's one more thing I can do.
Is it this sign over the cosine?
It's not the sine over the cosine. You're thinking of like a quotient rule or a quotient identity. The problem is that you have to be able to separate. You'd have to be able to separate the entire fraction. So if you wanted to, you could separate it so you have negative 6 over 4 cosine squared and then the 6 over that. You could separate it out like that as two separate fractions. I don't know that that necessarily cleans it up any better, but it wouldn't be wrong. There is something else that can be done, though. Yeah, everything has a factor of 2 in it. The coefficients do. You're right. So because everything's divisible by 2, we can simplify the divisibility, okay? So we can take a 2 out of each one of these coefficients, and then I have negative 3 plus 2. I'm sorry. Did I say that right? Yeah, plus 3. I guess I did say it wrong. Sine x over, and there's my 2 cosine squared of x. So are there other versions of things that could be correct? Well, yeah, if you separated this into two separate fractions and you saw, hey, I've got a negative 3 over a 2, and look, the cosine squared's in the denominator, and I could make that secant squared, and you could do a few other things, but I don't think that it actually simplifies the expression any to a different level, like where it compacts things or breaks them down into something smaller, right, like that. So this is a very acceptable answer at this point. We've cleaned up all the pieces that can be combined in a reasonable way. All right? Any questions?